as I didn't have any actual passions, I had to stick with one of the most basic things I know, chemistry. I chose the easiest thing that looks actually very difficult, silly string. You really only need 4 things for this project, which is ethyl methylcrylate, polysorbate 80, you can't even see ethyl methylcrylate, there you go, and R134A, and 99% isopropyl alcohol. In essence, it's not exactly silly string, but it's close enough and it's really easy to make. So I got these vials off of Amazon, and they were supposed to be a lot smaller than shown, but the main problem is these caps. We can't get the refrigerant in there efficiently, and effectively, I guess, because it needs to actually stay compressed and not have any actual oxygenated air. So I decided, okay, you know what, I'll just get some adapters for, the dispenser for R134A. I have like 3, and none of them work. So I was only left with like a few options, and I don't know what to do. So what you would first start off with is just a simple, into the vial, you get your polysorbate 80. Get about 10 milliliters in there. I'm not gonna put 10 milliliters in here because that's just a waste, but you get the point. Same thing with your 99% isopropyl alcohol. Get about the same amount. That's whatever. Once you have that, what you want to do is get 6 grams of your ethyl methylcrylate, put it in there as well. I think this is in one take, but whatever. You have your stuff, right? If you can tell, if you're relatively observant, or if they decide to show you, you can see it start to form, right? So we just put the cap on, obviously, shake it up, right? Just, shake, see what happens, right? It's supposed to get to a point where it's sort of translucent and has a viscosity of similar to water. What I need is a cap that supports either one of these 3 connectors to the R134A that I'm able to, attach and detach, basically. Because we don't want it to leak, but we also want to actually get the R134A in there. And that's where the problem comes in. I'm gonna just screw this on. So we use this one right here, right? Not a big deal. Just screw it on. Please God, tell me this is the right way. And then it's releasing, right? Only problem with that is if it's not fully contained in here, it'll just leak, and then I just wasted R134A, like I just did now, which wasn't really worth it for the demonstration because it was like $30, but it's whatever. I don't know how I'm gonna come up with this, but this project is due May 6th. It is currently, I believe, the 19th of April. So I was thinking, okay, why don't I just get this hose, put it here, right? Looks like it fits. Nope, it'll just come right off. So I was thinking, okay, let's just stick this in here. It's just gonna leak. I hope that at some point I can find some genius
To start things off, let me give you some basic information that you're going to need to understand the explanation of this, which won't be the best. So there are 2 types of polar molecules, those being protic and aprotic. A protic molecule is something that tends to have something called a hydroxyl group. This hydroxyl group is classified with an H and O at the end of the molecule, which allows this molecule to have something called a hydrogen bond. Aprotic, on the other hand, does not have a hydroxyl group. It instead has something called a carbonyl group. That's classified with a C and an O, or a C with something else. Because they don't have that hydroxyl group, they do not display hydrogen bonding. The solvents used in this reaction were the isopropyl alcohol, which is protic, and the tetrafluoroethane, which is R134A, which likes to bond with these protic molecules. If you ask me why this happens, I have one simple answer, and that is I have absolutely no idea. The tetrafluoroethane dissolves the ethyl methylcrylate, but it can't dissolve it fully. This is why the isopropyl alcohol is needed. The isopropanol dissolves the ethyl methylcrylate fully, and it brings it down to a viscosity similar to water. Once all that occurs, it is able to flow out of a nozzle, creating our silly string.